Greetings, class. Mr. Cowboy here today, and today we'll be looking at how to solve one-step and two-step equations. So this is basically the algebraic portion of the course here, and the techniques you'll be learning throughout this chapter will actually be applicable to all the chapters that we'll be looking at in this course. So guess what? Let's get right to it. So when we're solving for equations, what you're going to see is that ultimately what we want to do in each case is to perform what's called isolating the variable. So whenever you see a letter, okay, what you're going to do there is simply find the different strategies you can do or different techniques you can use in order to set it on its own. So when looking at an equation, every equation looks something like this. Now you notice that what we have there is a variable term or a term with a letter, specifically 2x, and what we have here are two numbers. Now you notice that you only have one equal sign between all the terms here, okay, or one equal sign within the equation. That's why it's called an equation. Now what we want to do is learn the various steps called opposite operations to isolate the variable, whatever that variable or letter may be. To solve an equation again means that we're going to perform the opposite operations to leave that particular letter alone. And this is also known as finding the root or finding the solution of the equation. So basically what we're going to do to start us off is we're going to look at the various one-step solutions in order for us to isolate the variable. Okay, and after that, we're going to see what happens when we combine two of those steps in a single question. And ultimately, what we want to do here is to leave the letter exactly where it is and basically take care of whatever is around it. And anytime you're given an equation, such as the one that you see on the screen there, the first thing you need to do here is to add or subtract the number that is separated from the variable there. So we're going to go through that method, and I'm actually going to use shapes and colors in order to do that. And then from there, what we want to do there to ultimately isolate the variable is to divide both sides by the coefficient or the number that is beside it. So that we're going to go through all that detail once we get to the two-step equations. But the first thing we need to do is start off with the basics and then use the basics to look at harder questions. So the first type of question we're going to look at is what happens when we add or subtract a number in order to isolate a variable. Now, if you take a look at the three examples you see on the screen there, what we have there is the letter X on one side, and we have numbers on both sides of the equal sign. So in each case here, our ultimate goal here is to leave the variable term alone. So that X is not going to move. So question is, what is going to move? Well, things that are surrounding it in order for us to leave that X alone. Now, anytime you see a variable term on its own, and there's a number that you're adding or subtract it right or just around it, what you want to do there is to take that number and move it to the other side, okay, performing the opposite operation. So what I mean by that, if you take a look at the first question, we have x plus 5 equals 11. So to isolate the x there, we're not going to move the x, but we're going to move the positive 5. Now, when this positive 5 goes the other side, okay, it subtracts itself from the 11 that's already there. Now, please pay attention to the form here and notice that we are writing all of our answers vertically, meaning from top to bottom, with only one equal sign per line. Now, when we do that, 11 minus 5, that gives me 6. Okay, that's pretty much it. So you're probably asking, well, what is the one step here? The one step is referring to the step where we actually subtract the 5 from the 11. Okay, so that's the one step for that particular problem. Now, for this next one, again, we want to leave the x by itself on that side there. So in this case, we are now moving a negative number, specifically the negative 9. Now, when a negative number goes the other side, you're then adding it to the number that's already there, which in this case here is negative 4. Now, anytime you're moving a number, okay, you always write it after the number that's already there. So in the next line, notice that what I have there is negative 4 plus 9. And they'll give us an answer there of 5. Now for part C, the only difference with this question compared to the other two is that the X happens to be in a different location, but you're going to see that the technique is exactly the same. So I'm going to leave the X where it is, and you notice that what we have there is a negative 7. So we're going to take the negative 7, okay, move to the other side, and then add to the 2 that's already there. So what we wind up getting there is X equals 9. So ultimately, anytime you see a variable and you have a number that's added or subtracted from it, okay, you move the number to the other side and then change the sign. That's probably the best way to explain it. All right. So in the next set of examples, before I proceed, notice that all these questions here has a variable and a number separated by a plus or a minus. So the reason why I'm bringing that up is if you take a look at these questions here, okay, notice the number and the letter are grouped together. Now, the operation that's grouping the number and the letter together is multiplication. So what we have to do in this case here is to perform the opposite operation of multiplication, okay, which is division. Now, you notice in blue there is to isolate the variable in each of the examples, you have to divide both sides by the coefficient, which is simply the number that's in front of the letter. So if you take a look at the first example here, what we're going to do here is to divide both sides here by 2. Now, when you do that, if you take a look at the left side, when you divide both sides by the coefficient, it simply just cancels out that coefficient. And you can now see that the x is by itself. And then negative 14 divided by 2 will give me negative 7. Now, for parts B and C, okay, you're going to see that when you're dividing both sides by the number that's attached to the variable, okay, if it's a negative, you also include the negative. So for example, for part B, I'm going to divide both sides here by negative 3. And what that does, it cancels out the 2 negative 3's on the left side, and then 15 divided by negative 3, that will give me negative 5. Now, I put a star beside this one here because, believe it or not, there is a number that is located in front of that x, specifically in between the negative sign and the x. Okay, and remember that anytime you see a variable by itself and there's no number in front, okay, there's really a 1 in front. And in this case here, it happens to be a negative 1. So in this case here, we're going to divide both sides here by negative 1. Okay, that cancels out the negative 1s on the left side, and we're left over with x equals negative 7 divided by negative 1, which gives me positive 7. Okay, so anytime you see a number and a letter grouped together, so that, like you see here, meaning the number and letter there's no sign in between them, okay, then you have to divide both sides by that particular number. Now, it doesn't matter what side the variable's on. Whatever the number is beside the variable, that's the number you divide it by. All right, the next set of examples, you might want to put a star beside these two because this is the one that people have a hard time understanding at first. But you're going to see as long as you understand the simple rule, when you have a fraction, it's exactly the same thing in each case. Now, what you need to know when you're looking at a fraction is that in order to get rid of a fraction, all you have to do here is to multiply both sides by the denominator. So what that means here is that you take a look at the bottom number, and whatever that bottom number is, that's what you multiply both sides by. So if you take a look at the first question, you notice the bottom number here is 5. So guess what? We're going to multiply both sides here by 5. Now, I want to explain why we need to do that. And in a similar fashion from the previous example, and basically what we want to do here, when we multiply both sides by the denominator, it cancels out the denominator. Now, if you take a look at the 2 red slashes there, that's just a visual representation of 2 numbers canceling out, and you can see here that the x is now on its own. And then 5 times 4, that'll give me 20. Now, the same applies to negative numbers. So even if you have a negative denominator, you still need to multiply both sides by that number, including the negative. Okay, and you notice here, just like the previous example, okay, the denominator cancels out, and then negative 6 times negative 8, that's going to give me positive 48. All right, so again, key thing that you want to see here is the instructions that's written in the blue. Whenever you see a fraction and you're involved in one-step solutions, you always just have to multiply both sides by the denominator. All right, let's move on here. Now, in the next part over here, we're now going to look at 2-step equations where we're going to combine 2 of the previous steps that we did in this lesson here. So in each question, we will be performing 2 of those steps. Now, in each case here, what you want to ultimately do is to leave the letter exactly where it is, okay? So when you're dealing with an equation and there's only one letter within the equation, such as what you see on the screen, you leave it alone until you have to deal with it. So for part A here, what I have here is 3x plus 5 is equal to 17. So again, first things first, you leave the 3x exactly where it is. So the first step that you need to do here, okay, is to take that 5 and move it to the other side. Okay, so we leave this sum alone until we have to deal with it. So you're going to take the 5 here. It's going to go to the other side and subtract itself from the 17. And then from there, 17 minus 5, that gives me 12. So of the two-step solutions, that's step number 1. Okay, in the next part over here, we now need to isolate the x. Now remember that the 3 and the x here are grouped together by multiplication. So what we need to do here is to divide both sides here by 3, and that'll give us an answer here of x is equal to 4. All right, for part B, again, exactly the same thing. The only difference in this case here is we're going to leave the negative 2x where it is. So let's take care of the negative 17 first. Okay, and it's going to go to the other side and add itself to the 14. Now this one here, we add the 17 here because what we have there on the left side is the negative 17. So when it goes the other side, it changes to the opposite sign, which is a positive, which then becomes addition. And then this will give me negative 2x is equal to 30. And last but not least, we divide both sides here by the coefficient, which is negative 2. And that cancels out the negative 2's on the left side. And the final answer for this will be x equals negative 15. Now that we have the two answers here, do we trust our answers? Well, yes, because I'm telling you, but there is a way to find out whether our answer is indeed correct. And that's perform what's called the left side and right side check. So if you take a look at the check over here, what we're going to do here is to take our answer, in this case here, x equals 4, and then we substitute it in for wherever there's an x. Now, when you're breaking this apart according to the left side, okay, the left side is strictly whatever's to the left of the equal sign, and the right side is strictly whatever is to the right of the equal sign. So, for example, what we have here is left side equals 3x plus 5 because that's what's on the left side, and 17 here is on the right side. So all I'm going to do here is going to put x equals 4 in for x and to see if the left side and the right side are the same. And as you can see, the left side and the right side have the exact same value. So we know that x equals 4 is indeed the correct answer. So let's do a check for the second one here. Again, same way. The left side here is negative 2x minus 17. The right side here is 13. So when you, what we're going to do here, we're going to replace the x here with the negative 15, just to make sure that this is indeed the correct answer. Okay, and sure enough, that is the correct answer to that. Now, common question was, well, what happens when we do the check and the left side and the right side are not the same? Okay, that's one of two reasons. You either got the answer incorrect or you did the check incorrectly. Okay, so again, make sure you do the you backtrack to see where your error might be if your checks don't check out. All right, so for the last part here, we're actually going to look at an example of mathematical modeling, which means you're going to take a word problem, create an expression for it, or in this case, an equation, and then solve it from there. So it says here, the student council raised $5,000 by selling hooded sweatshirts for $25 each. So the question we want to eventually answer here is, how many sweaters did the student council sell? So it says here, using S to represent the number of sweaters sold, write an algebraic expression which models the situation. Now, what we know so far is that S represents the number of sweaters sold. Now, the only thing we know so far is that each sweater costs $25 each. So a good way another way to explain that is, well, if you're paying for each sweater and it costs $25 each, that's 25 times S, okay? And remember that when you multiply a number to a letter or variable, you're just grouping them together as that. So what we have here is 25S. Now, what we also know is that they've sold all these sweaters to make $5,000. So what we have here ultimately is 25S is equal to 5,000. Okay, which is again an example of an algebraic expression, or in this case here an equation, because we have a letter as well as an equal sign that helps us model this relationship. So it says use the algebraic expression to solve for the number of sweaters sold. Now, as you can see, the 25 and the S are grouped together by multiplication. So what we have to do with that is to perform the opposite operation, which is division. Now remember, you always have to divide both sides by the coefficient, which is the number beside the letter. So when we do that, we divide both sides by 25, which cancels out the 25 on the left side. So we get a grand finale here of 200. And don't forget, this is a word problem, so don't forget to write down a therefore statement. So the student council sold 200 sweaters. All right, so that wraps up the equation, the question on equations here. So again, you can continue working on in your workbook or the textbook questions, and I'll see you in the next lesson.